Hello, beautiful people, and welcome. In today's video, we are going to practice graphing quadratic equations given in standard form. Now, I am going to be referring to some steps that we have done in a previous video. If you haven't watched that video, go ahead and do so before watching this one so you know what the steps are. Let's go ahead and jump into example number 1. Step number 1 is to make sure that you have it in standard form. Now, standard form is this form here. So you have ax squared plus bx plus c. I'm noticing that I have a x squared here. I'm noticing I have an x here. However, I don't have a constant, so I don't have this plus c. I'm going to put that in, and just by writing 0. So this is going to be my c. So here's your a, here's your b, here's your c. Now, once you have it in standard form, go ahead and find the axis of symmetry. So the axis of symmetry is going to be your x equals to your negative or opposite of your b value divided by 2 times your a value. Now, your a's and b's and c's come from your original equation. Make sure to take the symbol with the number that is to the left of it. So I have the opposite of negative 6 divided by 2 times negative 3, which is my a. Negative and a negative make a positive, so I have 6 divided by 3 and 2 make a 6. So I have 6 divided by 6, but I have a 1 here, which gives me a negative 1. So that means that my axis of symmetry is at x equals negative 1. And again, that's your axis of symmetry. Now, taking that x value, you're going to move on to step number 2. Step number 2 is asking you to find the vertex. Vertex is taking your axis of symmetry x value and plugging it into the original equation. So I'm going to copy down the original equation. You can, if you want to, add that c value, that 0. However, that wasn't your original equation, so you don't have to. Plus 0 doesn't really matter that much. So here I'm going to put a bubble anytime I see x, because inside of that bubble, I'm going to be putting in my negative 1 value. And then you're going to continue to solve and evaluate for your y value. So you're going to get y equals a number at the end. So I have negative 3 times negative 1 squared is a positive 1, minus 6 times negative 1. Keep multiplying things out. Negative 3 times 1 is a negative 3. Negative 6 times negative 1 is a positive 6. So y is equal to a positive 3. So that means for my vertex, I have an input of negative 1 and an output of positive 3. So that's step number 2. Step number 3 is asking you to find additional points on your curve, on your quadratic function. So how to do that is you're going to create a little t-chart here. And you're going to write your vertex point in the middle. So I have negative 1 and 3. Here are my inputs and here are my outputs for x and y. I'm going to choose 2 numbers that are very close to my vertex. For example, I'm going to choose 0 and I'm going to choose a positive 1. Now, the reason I'm choosing those numbers is because I want them to be very close to your vertex, so that way we can then later reflect across the axis of symmetry. So step number 3, let me change colors. Step number 3 is I'm going to take the original equation, so y equals negative 3 times x squared minus 6x, and I'm going to rewrite it and solve for my input of 0 and solve for my input of positive 1. So I'm going to leave some space for me to work with it. So again, our input is going to be 0 for one of them, and then the next one's going to be a positive 1 for the other one. So what do we have? We have 0 squared is 0. 0 times negative 3, this is 0. This is your y equals. And then 0 times 6 is 0, so we have y equals 0. So when our input is 0, our output is also 0. Let's try the next one. We have negative 3 times 1 squared is 1, minus 6 times 1 is 6. So I have a negative 3 minus 6, which gives me a 6, 7, 8, 9, negative 9. So when our input was 1, our output was a negative 9. Now I do have example number 2 here. I'm just going to highlight that. That's example number 2. That does not apply to this question. We're just going to move example number 2 to a different page since I'm running out of space here. All right, so now we have our step number 4, which is reflect across the axis of symmetry. In order for us to do step number 4, we actually have to go ahead and start graphing this. So I'm going to do my y-axis, I'm going to do my x-axis. And sketch this out. I have a point at 0, 0. My vertex is at -1, +3. And then I have a point at 1, so +1 and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be here. Our axis of symmetry was at x equals -1. So that means here's my axis of symmetry. And hopefully you caught that little hiccup that I just made. So for my input of +1, my output was a -9, not a +9. So I'm going to remove that, bring it down. 1, 2, 3, 4, 5, 6, 7, 8, 9 negative. That's going to be here. So now I'm going to reflect my points across the line of symmetry. So what that does is if you see a 1 jump to the right, you're going to do a 1 jump to the left. If you have 2 jumps, so 1, 2 jumps to the right, we're going to do 1, 2 jumps to the left. And so you should end up having points on the right side and on the left side of your axis of symmetry, and then you can just connect them down, making a U. Now we are going downwards, meaning a reflection has occurred across the x-axis, which does make sense if you look back up here to our original equation. We do have a negative out in front of our a value, which means that your axis of symmetry, your quadratic equation has been reflected across the x-axis, so you're going to have a upside down u, which that is what we had here. Let's go ahead and do one more example. Let's do example number 2, but on a separate sheet of paper. So our equation for example number 2 was x squared plus 8x plus 13 is equal to y, and that is example number 2. Step number 1, again, is to label your ABCs. So here's your A, here's your B, here's your C. Now make sure that you take the symbols in front of the number. So for example, if you don't have a number here, that number is 1. This one here is a +8. This one here is a +13. So step number 1, just like before in the previous example, let's see what our axis of symmetry is. And that is x equals to the opposite of b divided by 2 times your a value, which means that you have negative b, which is +8, divided by 2 times a, which is 1. So you have -8 divided by 2, which is a -4, and that's equal to your x value. That's going to be your axis of symmetry. Step number 2 is using that x value. You're going to plug and chug for your vertex. So you take your original equation, which is x squared plus 8x plus 13 is equal to y. Anytime you see an x, you're going to place a bubble there. And then into your bubble, you're going to put your x value, which you got here. In this case, it was a -4. Go ahead and simplify and evaluate this. So we have -4 times -4, so -4 squared. That equals to a +16. 8 positive times 4, that is a -32 because we have a -4, plus 13. So I'm just going to rewrite this. 16 minus 32 plus 13 is equal to y. And again, if you're in my class, feel free to use a calculator, so that way you can eliminate any small hiccups. So we have 16 minus 32 plus 13, that gives us a -3. So that means our vertex is at -4, comma, -3. So when our input was -4, our output was -3. Moving on to step number 3. Step number 3 was to find 2 additional points on the curve. So we're taking our original equation. Oops, that should be a 13. Again, we're placing bubbles where our x values should be. And I'm going to leave some space so that way I can solve it. And I want 2 other numbers to input and solve for y. Now, what are those numbers? You can do a t-chart kind of off to the side here. Write your vertex, and you want numbers that are very close to this x value. So I'm going to choose a -3, and I'm going to choose a -2. So first I'm going to do a -3 as my input. There should be a -3 here. And then I'll do a -2 as my input. Use a calculator if you need to. We're going to simplify. -3 times a -3 is a +9. -8 times, should be a negative or a positive? Oh, I miswrote the original equation. This should be a +8. I'm going to just verify that. Yes, so we have a +8 and +13. Almost made a mistake. So simplifying this, we have -3 times -3, which is +9. 8 times a -3, that should give us a -24. Then we have a +13. Again, using my calculator, I have 9 minus 24 plus 13. That gives us a -2. So when our input was -3, our output was -2. Let's do that one more time for our input of -2. So -2 times -2, that's a +4. 8 times -2, that is a -16. Plus 13, we'll do 4 minus 16 plus 13. That gives us a value, our output of 1. Now that we have our 3 points, we're going to start graphing and then do step number 4, which is to reflect across the axis of symmetry. So let's start with our vertex point. Our vertex was at -4 and -3. Here it is. That means we have an axis of symmetry at -4, which is going to be here. We have 2 more points. One of them is at -2 and 1. The other one was at -3 and -2. Now we are reflecting across that axis of symmetry. So I have 1 jump to the right here. That means I'm going to have 1 jump to the left. I have 2 jumps here, 1, 2. So that means I have 1, 2 jumps to the left and then 2 jumps to the right. Now I have 5 total points, which I am set to connect with a smooth U. Make sure you have arrows on your U. Now looking back at our original equation, notice that we do not have a negative in front of our leading coefficient. We had a positive A, therefore your curve should look like a happy face or a standard U. All right, beautiful people, thank you so much for watching this video. In the next one, we will talk about vertex form. Thank you so much. Have a great day.